Our design and plan. In order to approach the design of this project, we need what most deep learning software needs: data. Once we, of course, have that data, then it comes up to us with how to use it to best find the balance between protecting data, protecting users, and supplying them and not overreaching. This data from what users of a program are expected to do will establish a baseline from which we can interpret malicious data using deep learning and neural networks. Everything will be open to observation by the neural network. We will choose not to limit with consent from the users. We will choose not to limit the neural network to only, for instance, the choices that are made, the pages which are opened. A malicious software can reveal itself through faulty IP addresses or suspicious VPNs, or even the speed at which it's able to move through pages which no ordinary user would do, no non-malicious user would do. So we will need to establish regular activity through users. First, we will use the software ourselves as the developers to build an obvious database to allow the activity before opening it to random users to serve the defined program. Once these foundations have been set by us first and then by general users, we will have a good metric about what ordinary activity is and what we should and should not punish and lock out and defend. We will do this through a combination of four measures: the cost of a disgruntled user, the cost of a successful malicious attack, the rate of a wrongly turned away user, and the rate of a successful attack. We will then create a mathematically perfect degree of specificity which minimizes risk and maximizes satisfaction. Why is the balance important? We cannot make the mistake of assuming and getting it wrong for friendly users is just as bad. We cannot make the mistake of assuming getting it wrong for friendly users is just as bad as getting it wrong for evil users. To simply look at the proportion of user-reported lockouts and see that we have a 10-to-1 relationship with successful breaches is not evidence to say we have moved too far or too stringent with our users. We are blocking out far more than we are getting reported hacks. We know that the malicious intent, the malicious results are far worse than a temporarily turned away customer is bad. A temporarily turned away customer will perhaps be able to come right back on the site. A missed attack could result in all customers being blocked off the site or having their information compromised. Obviously, the genius of the deep learning software is not the algorithmic balances of risk. The genius is that it will become better with more data. However, as a ever improved version, the balance of risk, algorithmically calculated, will be an incredible tool.
Alternatively, we could take a labeled database of legitimate users and known malicious users. Hand labeling a large database the size we would need to train the algorithm would be far too time consuming. We considered that there may be a pre-labeled database that we could get access to, in which case we could use that to train our algorithm. Otherwise, we may have to opt for unsupervised learning. In the case that we do use an unsupervised learning algorithm, we will want to know just how effective it is. One of the ways we will measure the potential usefulness of our algorithm is by comparing its speed and accuracy against that of a human. To do this, we will use a smaller data set than we use to train the algorithm, since it will be impossible for a human participant to process as much as a machine. Both our algorithm and the human participant will have to decide what activity is malicious and which are not. Their times will be measured and their accuracy as well. We expect our algorithm to complete much faster than a human can, but we will compare the difference in speed against the difference in accuracy in order to better judge the value of our algorithm. If our method is much faster but not nearly as accurate, it may be useless. However, if it is within a reasonable margin of accuracy, the time saved may be worth a few wrong assumptions. There also exists the possibility that our algorithm is more accurate than a human. This project presents some potential challenges for our group. Out of an abundance of caution, we will be collaborating remotely only. This can make it difficult to coordinate in real time. Also, many of the members of our group have other commitments, work, children, etc., that may make scheduling time to work together on this project difficult. To solve these challenges, we will make a schedule of dates in which we will be able to work together and relay our individual progress.